All right, welcome back, folks. We are going to do something kind of fun right now. We are going to look at the single most involved, I don't want to say the single hardest, but I will say the single most involved question in all of Physics 11. So, got the little note there, fasten your seatbelts. Got a picture here from inside an airplane landing on an aircraft carrier. So I would assume that if you could fly an airplane, that this activity, landing your plane on a moving runway in the middle of the ocean, would probably be the culmination of a lot of piloting skill that you had developed over time. And this question we're going to look at today, a specific kind of collision question, is actually the physics version of the aircraft carrier. We've been building a whole bunch of skills right from chapter 1 with like math warm-up and scientific notation and talking about units, and we've looked at kinematics, and we've talked about all kinds of math and all kinds of physics. And we're going to put all of that together into one question here. So we started out slow, right? Here's your first couple chapters, getting used to some algebra, maybe some word problems. It's like flying the Cessna. And then we've ramped her up pretty quick here. We are now going to put our airplane on the aircraft carrier. We're going to put all our skills together and do something pretty cool. So you've been working hard to get to this question. It's kind of a crazy question, but it's pretty neat that you have the skills that you can do a question like this. So let's jump in and see what it looks like. Okay, so just like the last video, hopefully you remember, this is the same before scenario, actually, before the collision. Last lesson, we saw off of this before scenario, two different after the collision scenarios, one where the objects stuck together, one where the objects hit and bounced apart. We looked at those questions in terms of finding a final velocity using momentum, and then we looked at finding heat energy by looking at kinetic energy. Today, same before scenario, but here's the after. After number 3, we're going to find both velocities. I'm not going to give you one of the velocities after the collision. There's actually 2 unknowns. Now, in order for us to solve this, I do have to give you one other little bit of information. I have to tell you that the collision is elastic. So that means not only is momentum conserved, as it is in all collisions, but an elastic collision means that the kinetic energy is also conserved. And that's going to help us get through this question. Again, it's going to take us a while, but that's okay. We get to do a lot of cool stuff. So, first things first. You want to start with momentum. Just like always. What we want to do here when we are working with momentum is we want to solve for VA or VB. And it turns out it doesn't really matter which one you solve for. So let's do a before and after. Sigma pi equals sigma pf. We have 8 times 5 plus 6 times, remember it's negative 2 because that object is moving to the left, equals 8 VA plus 6 VB. I think we had that left-hand side work out to be 28, if I remember right from the last video, equals 8 VA plus 6 VB. Now in this case you can solve for, like I said, either VA or VB. It doesn't really matter. I'm actually going to solve for VA just because there's an 8 in front of it, and 8 is actually just 2 times 2 times 2. Things divide nicely by 2. 6 is a 2 times 3 in terms of a prime factorization, and things don't divide as nicely by 3. So I'm going to subtract 6 VB from both sides. That's going to leave me with 28 minus 6 VB equals 8 VA. And then we want to divide everything by 8, but I don't want to leave it as a fraction. I actually want to divide every individual term by 8. And I have to check on the calculator here. What is 28 over 8? So 3.5. So we're left with this equation. 3.5 minus 6 over 8 is 3/4, so 0.75 VB. That is equal to VA. And I'm going to put a big box around that equation because we're actually going to use it again a few times. That's an important equation for us in this question. So there's the first part. We don't really have just a number answer. You'll notice our answer has a variable in it, but that's okay. Now what we're going to do is we're going to switch away from momentum and we're going to move into kinetic energy. So now we know in this case, because I told you the collision is elastic, we know that the initial kinetic energy is equal to the final kinetic energy. There is no heat that I have to worry about putting on that right-hand side. So again, I'm going to go back to this line right here, and I'm going to start changing the m's and v's into 1/2 mv squareds. So I've got 1/2 times 8 times 5 squared plus 1/2 times 6 times, I'm just going to call it 2 squared, not the -2. I don't want to have to worry about the brackets on my calculator. Equals 1/2 times 8 times VA squared plus 1/2 times 6 times VB squared. Now what I want us to do is clean up that left-hand side. I think from the last video it came out at 112 equals, I might as well figure out what 1/2 of 8 and 1/2 of 6 is. That leaves us with 4 VA squared plus 3 VB squared. And as of right now, that is sort of as far as I can go with that equation. But I bet some of you are seeing what we're going to do. We are going to run a little substitution where we can take this equation here that's in the pink box. We know that VA is equal to this term that includes a VB. So we're actually going to grab it and we're going to plug it in right there. The kind of crummy part for us here is that it's not just 4 times VA, it's actually VA squared. So it's 4 times. That term squared means I have to put it in there twice. 3.5 minus 0.75 VB multiplied by 3.5 minus 0.75 VB. And I don't want to forget about this lonely old 3 VB squared hanging out on the end there. So at this stage, you can see the first thing we're going to have to do is with these two binomials is we're going to have to run FOIL. Everybody's favorite thing from math class. So let's try that out. 112 equals 4. Now the stuff that I FOIL, I'm going to do in red here, just to show that I'm doing it one step at a time. I have to FOIL first, and then we can deal with distributing the 4 and multiplying everything by 4. Again, you probably remember from math class that there are little memory sort of devices or mnemonic things to do FOIL, but firsts, outsides, insides, lasts, double the first, or how's it go? Square the first, square the last, multiply and double. There are some different sayings, but we'll have to take the 3.5 times 3.5, which is going to give us 12.25. Then we're going to take the 3.5, we're going to multiply by a negative 0.75 VB, which gives us negative 2.625. And then there's going to be a second one of those terms right here when we multiply again. So I'm going to go ahead and double that. So there's a minus 5.25 VB. And then we've got the last step here, negative 0.75 VB times negative 0.75 VB. It's going to come out as a positive, so I'm just going to type it in as 0.75 squared. That gives us a 0.5625, and that's positive, VB squared. And we don't want to forget about having this lonely old 3 VB squared still hanging out on the end. So now that we've taken care of FOIL, now we can distribute that 4. So that 4 is going to excuse me, multiply everything in the brackets here. So we're going to quadruple all of that stuff. 112 equals 1225 times 4 is 49. Minus, that's going to be a 21, I believe. 21 VB. Ooh, and I'm going to need a calculator for this one. Plus 0.5625 times 4, 2.25 VB squared. And we've still got that lonely old 3 VB squared hanging out on the end. At this point, I think you're going to recognize that we get to do the other thing that you love from math class, which is quad formula. And again, this wouldn't be the aircraft carrier if we didn't have all these math skills sort of wrapped into one. So we've got like FOIL, distribution, substitution, quad formula. It's beautiful. Let's call it that. That means we're going to want to set this equation equal to 0. So I'm going to subtract the 112 from both sides. So that's going to leave us with 0 equals